Here's an example of three equations and three unknowns, and we want to solve this system of linear equations. This system certainly is solvable by several methods, but we're going to look at transforming this system into an equivalent system that is said to be in row echelon form. Recall what row echelon form looks like. It has this stair-step pattern. The leading coefficients are 1, and there are 3 terms in the first row, 2 in the second, and just 1 in the third. And then we use a method called back substitution to come up with our x and y and z. So let's look at that system as it stands and notice that the first row is in form. It needs no transformation. The leading coefficient is 1. It has 3 terms. It's good to go. The second, well, we need to get rid of that x term. And notice that if we take the first row and the second row, we could add them together, creating a new row to replace row 2. So that's exactly what we do. We add the previous row 1 and row 2 together, coming up with a new row 2. We're going to do the same for row 3. That is, we're going to replace row 3, and first to start, we're just going to get rid of the x term. And this one is a little more challenging, not too bad. We're going to take the opening row, multiply by -2, add it to the third row, replacing the third row. Now, you could have done the same thing by taking the second row, doubling the second row, and adding to the third row to get rid of the x term. So there are options, but let's just go with -2 times the opening row times the last row, replacing the last row. And notice that that results in -y minus z equals -1. At this point, you might want to stop the video, take a look for yourselves, make sure that you understand clearly where row 2 and row 3, the new row 2, the new row 3, where they come from. So now we want to continue, and it seems to me that yes, the first row is in shape. It's exactly the way it needs to be. And the second row now is also in shape. There's no need to change it. And to fix the last row, the method seems quite apparent. That is to say, let's take the new row 2 and add it to the row 3, the new row 3, and get this brand new row 3 where the y's drop out, and we have 2z equals 4. The last change to get it into what's called row echelon form is to take that last row and cut it in half. Because if we do that, we'll now have 1z equals 2. To come up with our solution, well, we've already got that z equals 2. We're going to back substitute into row 2. We'll put 2 in for z and quickly solve for the fact that y equals -1. And when we put 2 and -1 into the first row, we can solve for x, and x must be 1. Most people will take that solution set and express it as an ordered triplet, that is, with the x, y, and z in that order, surrounded by a set of parentheses. What it means is these 3 lines are in space and they are consistent. That is to say, they meet at a single point.